Good afternoon, everybody. My name is Cormac Hogan, not Frank Denneman or Duncan Epping, if you were in the opening keynote. Apparently 20% of you thought I was Frank Denneman. Whatever. So I'm here to talk to you today about Data Services Manager. Now, I've spoken to various VMUGs in the Nordics over the last 10 years or so. Been to Norway, Sweden, been here in Denmark a bunch of times. And a lot of the time I was talking about storage. So vSAN, vVols, VMFS, all that kind of stuff. So we were thinking, well, okay, we've done a lot of work with the bits, the bytes, the blocks. Can we help you move up the stack a little bit and manage the data that sits on top of that storage infrastructure? So that's kind of what Data Services Manager is all about. So as part of trying to figure out, can we help our customers move up the stack? What are the areas maybe that we could focus on? We actually talked to a bunch of customers, and those customers had a particular problem with developers and development teams, in that those development teams didn't really want to go through IT for any data services. They didn't want to be opening tickets just to get a database. And a lot of times, if there was any sort of delay in getting a database rolled out, the developers would go off and do their own thing anyway. So they'd end up just deploying their own database just to get going. So this had a lot of problems for the IT teams. And you could loosely compare the IT teams, I guess, to the vSphere teams. How are they going to manage or monitor these databases that are going to be rolled out? How could they control them? How could they lifecycle management them? In other words, if there was a patch for Postgres came out that was a critical patch, how could they roll that out across the fleet of databases? So this is where we're coming from with the Data Services Manager. We're going to try and allow the developers to be as agile as possible in self-service databases on top of vSphere infrastructure, while at the same time being able to manage those databases, have visibility into those databases, and do all of the nice things like lifecycle management, automated backups, and that kind of thing. That's essentially what we're aiming for with this product. So, in a nutshell, this is what DSM 1.5, that was the release that we just brought out in May of this year, is trying to achieve. So it is about self-service, or database as a service, if you will, for developers to be very agile. And I'm just using that as one use case. There could be other use cases that you see as well as we go through this presentation. But it's really about allowing developers to be agile, or having users of databases have this self-service, while at the same time being able to manage and monitor and control those databases. So hopefully that makes sense as we go through the presentation. So there's only a couple of building blocks here. I mean, you should all be very much familiar with the vSphere infrastructure part. But what we do is we roll out two components that are part of Data Services Manager. There is the provider, which is essentially the interface that allows you to make requests for creating databases, deleting databases, all of that stuff. And then there's the agent, which is the part that implements the requests that come from the provider. Okay? So we come along, we requested to create some databases. So we build out these VMs, and I'm highlighting the resources that are being used as well, because the big part of this is being able to manage the resources that are around the databases that are being provisioned. So once we have the VMs rolled out and we have the resources allocated, we can go ahead then and provision the databases in those VMs. So you might notice that they are containers. So that's how we're implementing the databases on these virtual machines. But again, the idea is that it is self-service, and you do have control over the vSphere resources that are being consumed by these databases. The other thing I want to talk about, or the other few things that I do want to talk about, obviously the end users would consume them, but I want to talk about the integration we have with the full vSphere stack, because we are aiming this at the vSphere administrators. So we do want to show you how it is integrated with I'm going to say vRealize automation, ARIA automation, whatever it's called at the moment. Log Insight, ARIA operations for logs, I think. Did I get that one right? Thank you very much. Woo. And there's also Swagger API, or an API implemented through Swagger, which I'll show you later on, can also be consumed very easily by ARIA automation. That's okay, right? ARIA automation, we didn't change that. Okay, so that's kind of what I'm going to show you over the next 40 minutes or so. Now, when I first started on this presentation, Lisa Lott has told me, oh, this is going to be a deep dive, okay? So you've got to do deep dive stuff at this. I said, okay, that's interesting. So I sort of got my inner Frank Deneman going, thinking about this. So I thought, okay, yeah, this will be cool. We'll put together and we'll talk about all the components and services inside the provider. And we'll spend about 10 or 15 minutes talking about that. And then we'll go on and we'll talk about all the bits that are inside the agent and how that's provisioning databases. And then when the database is provisioned, we'll actually show you what's inside in the database VM. And then I said, you should ask one question. Has anyone here used Data Services Manager? Okay, that's what I thought. So I said, okay, I think I'll show you something that might be a little bit more useful than actually going deep dive into what's happening inside in all the different appliances. Okay, so really, all you really need to know about the architecture, and we've kind of touched on it already actually, it's essentially these components. We have the provider. The provider is what gives you that interface. It gives the admin the interface to requesting that database is being created, but it also has all the setup and all the configuration that's required there. The agent component is what's carrying out the operations that are requested by the provider, and the net result, as we saw, is a bunch of VMs that are provisioned that runs databases. There's a few things external to all of that. Obviously, it's on vSphere infrastructure, so we want to control the resources that are being consumed by the vSphere, or by whoever is creating these databases. Interesting thing as well, this is fully supported by VMware, including the database images. So we are providing you with the database images that are provisioned as well. So it's a fully supported stack that we're offering here. The one thing that's sort of outside the realm of VMware support at the moment is the requirement on S3 buckets. So you do have to have an S3 object store. We use them extensively for holding database template images, for shipping logs to them as well. For backups and restore, we use S3 buckets. So these can be in the cloud, be on-prem, whatever the case may be. Cool. Now, even in 1.5, we made it even simpler for smaller deployments where the provider and the agent VM, my clicker will work now, yay, are consolidated. It's a single VM. So if you had just a single vSphere cluster that you wanted to deploy databases onto, straightforward, single VM deployment is all that's needed. But if you had many vSphere clusters and lots of infrastructure and you wanted to provision databases across lots of different vSphere infrastructures, you would need an agent on each of those. So there would still be a requirement to have a separate agent. Okay. Now, all of this really is around making sure that the developer or the end user of your database, when you give them self-service, are not going to crap all over your vSphere infrastructure, for want of a better term. Okay? So we really want to control what resources they can consume when they provision databases. So there's a few things here. We have this concept of the environment, which is associated with the agent. That's typically a vSphere cluster, could be a resource pool even, something like that. But within that vSphere cluster, within that resource pool, could be lots of data stores, could be lots of VM networks. We have this concept of a namespace, which I hate using namespace because it's used everywhere now, but it's essentially giving you a fine-grained resource allocation. So it's still the same cluster, it's still the same resource pool, but what you're able to do is select dedicated data stores for provisioning the databases, and then selecting dedicated VM networks for allowing the connectivity to the database as well. Now, once we have the namespace created, we can come back to this organization concept, and you can say, this group of users is allowed to use this group of resources. But there's even more fine-grained than that as well, because if you give certain users, I'll just say certain users, access to a set of resources and tell them, yeah, you can go build VMs and you can go build databases, what do you think they're going to do? Remember this guy? So they're going to build the biggest thing possible, right? Again, so we have this concept of a VM plan, which is essentially a way of defining this is the maximum size of the virtual machine that you can build for your database. Okay? Now, you might trust your users and you don't have to go through the VM plan option, but if you don't trust your users and they're liable to do something funky, you can control the size of the VMs that they build as well. So let's put all that together. We have, let's say, a cluster of vSphere resources. Within that cluster, we can build multiple namespaces. They're consuming the same CPU and memory, but we can give them different data stores, we can give them different networks, give them different S3 buckets. Once we have the namespace created, we can define a set of users and say, you can provision databases as a service onto this set of resources. And then if we don't trust them, we can put VM plans on top of that and control the access as well. So that's kind of how we're managing all of the resources within the Data Services Manager product. Okay, all makes sense, kind of? Okay, cool. So what databases do we support? So we have 3. Postgres is huge. It's a massive amount of virtual machine workloads, let's say. If we look at the telemetry that we're getting back into a VMware from the workloads that are being deployed on vSphere infrastructure, by far the biggest database is Postgres. So that's one we definitely wanted to do. MySQL is another one. These are both open source databases. So we support both of those. And then kind of an outlier is SQL Server. And yes, we know there's a lot of SQL Server out there. And often when I give this talk, there's sort of SQL Server on containers. Oh, I'd never touch that. And you get that from a lot of DBAs who've been using SQL Server for years on Windows. But then you go, but do you use SQL Server on Azure? Oh yeah. Oh, how do you think they do it on Azure? They're using containers, right? And they go, okay, maybe, you know. So, but I would say this is an outlier, but these definitely, Postgres and MySQL, definitely a lot of interest in those two. Okay, now let's go and have a look at a demo on how we actually create a database. So this is our provider portal, and as you can see, there's a bunch of databases, and it's all being configured with the resources, namespaces, and so on. But there are a bunch of namespaces here, and what I'm going to do is I'm going to create a new database now. First thing, I'm going to select one of the namespaces, and then I'm going to decide, well, do I want to do Postgres, MySQL, SQL Server on Linux, or for Linux, or whatever. In this case, I'm going to do a Postgres one, and I'm going to select one of the Postgres versions that we support as well. You can give the virtual machine a name, or we give it a default name, but obviously you can change that. But also we're able to create a database. So not only do we create the database instance, but we create a database as well, and the default name we give that is DB as a service. You can change the password for the admin access to that database. You can add tags. So like if you had a large fleet of databases that are all being managed by this provider, you can use tags to find them. You can now control the resources as well. So in this particular case, there is no plan. So we're giving them free access to build whatever size they want. I will come back and discuss all of these configuration options like backup, maintenance window, and so on with you in just a moment. We could also deploy clustered databases, and there's a reason for that as well, which I'll come back to. So other things we can do, we can actually do advanced options. So you could set advanced options from the database at this point, but we can come back and change those as well later on once the database is fully provisioned. So that's essentially it. You can see there's a lot of configuration options that are available here, but you could just provision the default as well, absolutely. So it goes through a bunch of different stages. I won't keep you watching this. I have sped this up. I think it usually takes about 10 minutes because there's a VM provision operation takes place. But essentially what we're doing is we're creating a virtual machine. We're pulling down the software that's required for building the database within that virtual machine, and then we're actually provisioning that database within the virtual machine as well. The last thing we do, if it has been set in the configuration, is that we will make a backup automatically, a backup of that virtual machine as well. So that's it. As I said, I did speed this up quite a bit, but at this point, we do have a virtual machine that has been provisioned, and you can go back and you can look at lots of the different features that we have around automated backups, lifecycle management, and so on and so forth. Here you're seeing that the backups have been taken place. In this particular one as well, we're talking about the maintenance windows that we set up. Again, I'll come back to why that's important and why it's quite a neat feature of Data Services Manager as well. Okay, so we have provisioned the database. We've had a look at a lot of things just to show you that it's not smoke and mirrors and that there's an actual database behind this. I'm going to use a tool called pgadmin, which is a very popular database administration tool for Postgres, and just show you that we connect now to the databases, use the privileges that we set up during the configuration stage. So when we create a Postgres database, there is I suppose an instance we should say, there is a Postgres database, and there's also our DB as a service database that we created by default as well. And you can see it's a fully blown database there. So again, it's two sides of the house, I guess. Developers or end users being able to seamlessly provision databases, but you as the IT team, the vSphere administrators, being able to manage, monitor, control those databases that have been rolled out. So there was a few things now we saw during that demonstration that I want to come back to. The first thing was there was an option to select enhanced monitoring. The difference between standard and enhanced monitoring is the standard monitoring sort of gives you the virtual machine metrics, whereas the enhanced monitoring will give you database metrics as well. So you'll get this about memory, CPU, and so on, no matter what option you've set. But if you've gone with the enhanced metrics, you can see the activity on the database, like rows inserted, rows deleted, rows updated, that kind of thing. So it could be quite useful. The other thing we saw was the automated backup configuration. So I left that, it's on by default, and essentially what it does is once the database has been stood up, we'll automatically start backing up that database. So the retention policy, so actually there's two configuration options here. There's a local backup and there's a cloud-based backup. The local backup is a retention policy of 7 days. So we'll do a full backup and then 7 incrementals, and then we'll go back and do another full backup again. There's also a cloud-based one, and I think we just picked a retention policy of like 3 months, which is why that 91 days looks a bit weird, but it sort of matches what's also happening with cloud-based databases and that kind of thing. So once that's up and running, you'll see all of the backups will be available in each of the different database views. So again, you can do self-service on-the-fly backups. You could do restores of a particular backup, but you can also do a point-in-time restore as well. So you can look for a date or a time to match the restore. And what we'll do is with the WAL logs, write-ahead logs, I think they're called, which we also capture as part of the database, we try and narrow into a particular time to restore to as well. So that's all in there. Those 3 dots for the actions, essentially they give you a restore, a point in time, and you can delete backups as well. Okay, all good? Okay, cool. What else? The maintenance and updates is the big part of this. I mean, anybody can provision a database, right? So what we're trying to show you is that we're putting a lot of these kind of concepts around the database that it makes the administrator's life so much easier. And the maintenance and update is all around this as well. So again, think of the situation where Postgres or MySQL have brought out a new update, and now it's got some critical security issues associated with it. You've got to roll this out to your complete fleet of databases. If you didn't have a product similar to this, you're going around looking at all the different databases that all the different developers have, and you're trying to do that manually. What we can do here is we can actually do it automatically. And with the maintenance window that we set when we set up the maintenance policy, there's a feature called Auto Minor Version Update. So if there's a new minor version comes out, particularly for Postgres, we will apply that automatically to all the databases during the maintenance window, which is usually sometime early on a Sunday morning. So we have that built in as well. And not only that, because we obviously bring out versions of the provider and versions of the agent. The provider would have to be updated manually by the administrator, but once the provider has been updated, we can actually update all the agents in your infrastructure as well. There's a maintenance window for the agents as well. So I think I'm just showing you that one there. Yeah, so you can set that. Again, you could set it to the weekend when nobody is working on the databases, perhaps, something like that. And it'll trigger the agents to be updated without you having to be there to do the task manually. Great. So again, the thing about Data Services Manager is it's all around managing the day two operations or making the day two operations somewhat more easier for the administrator. So I have a bunch more here. We've kind of touched on a lot of these already. Certainly we've touched on the lifecycle management. What we haven't touched on is you could actually scale out these database VMs as well. So for instance, if you find that you provisioned a database with a particular VM plan and now you're starting to hit resource limits, you can scale out to a different VM plan that has additional resources as well. Also, there's the option of cloning the database from within the provider as well. So a lot of the times developers want to work on the latest and greatest data that they get from customers. So it could be that you could schedule a clone operation on a Sunday night. So when a developer comes in to start doing additional work on Monday morning, they have a clone of the most recent customer data available to do that. From the monitoring and automation perspective, I'll get a little bit more into that. But what I did want to touch on is we do have enhanced monitoring in the product itself, but we do integrate with the Araya stack as well. So the Araya operations for logs, and Araya automation as well. Araya or Aria? Aria. I'm going to blame my Irish accent. We call it Aria in Ireland, yeah, okay. And again, yeah, the full Swagger API, which makes it, and I'll show you again, because we show every payload from any of the operations that you do inside in the provider UI. You can see the full payload of what's going on, which makes it really easy to actually automate if you're doing something in Aria automation. The availability, we've talked about the backups already. Backup restores, all of that stuff is done automatically. Because they're VMs, you can use vSphere HA. Absolutely, if an ESXi host goes down, we have HA will restart the VM on a remaining node in the cluster. But for lifecycle management, what's interesting is that you can also cluster these databases. So you can build replicas. The databases can be built with replicas. And what that means is that if you're going through a patch update, we can do a rolling upgrade of the database, leaving it online for the duration of the patching as well. So it's probably belt and braces, if you want to call it like that. Obviously, you're going to consume a lot more resources. It could be that you're already protecting the data underneath with, you know, some sort of replication technology or vSAN or something like that. But then you're protecting it again at the application layer. But what it does give you is minimal downtime or even more availability. With standalone databases, which you can absolutely provision, when these go through a life cycle or an update, they need to be restarted. So there is going to be a temporary outage. But if you did have database clustering implemented, you avoid that outage during the life cycle as well. Cool. Okay, so we have some interesting things as well. I mean, it's not a static database now that you've just provisioned. You can go ahead and you can change things after the fact. One of the things you probably definitely want to do I'm not sure if that makes sense, but probably want to put on some sort of security and protection, and that's enabling TLS, or what used to be called SSL, so that connections to the database can only be made when they're trusted. So yeah, there's for those of you who do Postgres, there's a pghba.conf file in the Postgres configuration that controls the access. You don't have to go down into the virtual machine, modify that file, start the database up again. We can do that from the UI by setting the TLS there. And you can see you could download the certificates if you wanted to do that secure access to the database afterwards. Similarly, we saw a little bit of some of the advanced options for the database. I've switched to MySQL here now. And again, through the UI, you can make advanced option changes for the database through the provider UI. You don't have to get down into the database and modify the options file. You can, absolutely, but you don't necessarily have to. Okay. So alerting and monitoring on a fleet of databases then. So we have some pretty cool things built in to the provider as well, just again to deal with having a large fleet of databases used lots of different users, lots of different developers across lots of different vSphere infrastructures. So a very simple thing is just SMTP traps, not traps, email, SMTP, yeah, for emails. So here, if there's a change in the status of any of the databases, what you can do is configure it to send you an email. So you're notified through email that something has changed on any of the database. It's a very simple configuration. What we're looking at here is just the options page in the provider UI, and that's just an example of one of the emails that it sends out. Possibly more interesting these days, because I think most of us are using something like this probably on a daily basis, is Slack notifications. So you can build an application in Slack. There's a few things you have to do. You have to select a particular workspace for the application. And then you have to, once it has been enabled for webhooks, you would tell it, send notifications to this channel in my workspace. And so over here, you can see that this application is sending Slack notifications because the database status has changed. So again, if you had a team, an IT team, and they're on a Slack channel, they could absolutely just monitor this, and we will send updates and events based on what's happening to the database into that Slack channel. It's pretty neat, pretty cool. And it's, I mean, personally speaking, I found it very straightforward to set this up. I was thinking that this was going to be quite a daunting task to do. It's very straightforward, actually. Cool, okay. So I suppose getting close to the last topic is really just to recap on what I said previously, is that this is really, we're gearing this now towards vSphere administrators. And one of the things we wanted to make sure is that this is fully integrated into the full vSphere stack for monitoring, automation, logging, and so on. So that's what I'm going to talk a little bit about here over the next couple of slides. So I did say that there was a full-blown Swagger API associated with this product and all the different components of this product. So you just connect to the URL and it'll show you pretty much everything you need to do. So it is pretty comprehensive, and there's anything you can do through the UI, you can pretty much do through the API as well. Okay, there's a bit of a write-up here, but I don't think I need to get into it. I think you'll get the idea. Okay, so what that means then is that if we do something with, oh yeah, and I'm getting ahead of myself. I mentioned this previously. I mentioned that every operation that takes place in the provider UI, from creating a database, deleting a database, scaling up a database, backing up a database, whatever the case may be, the payload, and my voice is going, the payload is visible in the UI. So you can see the full payload there of what's actually happening as you go into each of the operations. And every operation will appear as shown there. So again, because we're able to see that payload, it becomes quite straightforward to be able to figure out, okay, I want to automate this. Want to make API calls to automate it. What is it that I need to be putting into the API call? So, cool. And it's especially true when we get onto something like ARIA automation. Again, this is a colleague of mine just built this out, and it's a 3-tier app, where there's like a web front end, some middleware thing in the middle, and then we're using a database at the back end, but the database has been provisioned through DSM. So we simply made the calls into DSM, You just fill out the template, which is essentially the template you saw me filling out in the demo, but you just do it through ARIA automation instead. Ship that off as a payload to the DSM Swagger API endpoints. Boop, we have a database provisioned through ARIA automation via DSM. Okay, so he's got a very nice demo on that actually. Okay, I missed something. Okay, there we go. So the next thing then is ARIA operations or VR ops or via realize operations. Again, we have some monitoring built into the provider UI, but I know a lot of our customers are already using ARIA operations for monitoring everything at the full stack essentially of their vSphere infrastructure. We just wanted to highlight the fact that the databases that you are provisioning through Data Services Manager absolutely can hook into that as well. Now you will need the true visibility management packs, is it? Yeah. So we have, I think there's loads of management packs, but the true visibility ones, there's a few there for databases. They have a Postgres one, they have a MySQL one, they have a bunch of others as well. But again, did that work? There we go. So again, if you have those management packs, you just build the accounts, you fill in the credential details for accessing the database and which database you want to monitor. And out the other end, you get your heat maps and all of the rest of the good stuff that we offer in ARIA operations. So there's nothing weird about these databases. They are fully blown databases that can be monitored in just the same way as any of the other databases that you might have. Okay. Last but not least is just to talk to you a little bit about the integration with ARIA operations for logs or log insight, whatever you want to call it. This is built in to Data Services Manager, and it's as simple as sliding a button, populating the information about your log insight server, and that's it. And what you can do is you can send the logs from the provider, you can send the logs from the agents, and you can send the logs from the database VMs all through a simple setup here. So the agents are already on the databases. When they're provisioned, by you enabling this option, it turns on the agent within the database VMs and you start getting your logs being sent straight away to your log insight server. So just to show you a simple example there of the, I suppose, the raw data coming in and then building some nice dashboards out of it. Do many of you use log insight? Great, okay, very good, very good. So I think I've come to the end. I've no idea if I'm early, if I'm late. I think I'm about on time. Oh, I still have plenty of time. So I'm going to show you one last slide, if this thing would work. And we have a couple of, who's going to explore, by the way? Cool. So we have some interesting announcements that I can't talk about here in relation to this product. A lot of significant announcements. If you have an opportunity to attend some of the sessions, please do. Hopefully have some more news to share with you. But it looks like I have lots of time for Q&A. So please, anyone have any questions about Data Services Manager? Yes, go ahead.
The list of databases, MongoDB?
Yeah, so we've had so many like MariaDB, MongoDB, Cassandra's, and even our own portfolio like the Green Plums and all of that kind of stuff. All I can say is we're focusing right now on getting PostgreSQL and MySQL done extremely well. Just really nailing those two databases down, and hopefully we will be able to expand on that very soon. And there's a follow-up question. So I know that we can add replicas to MySQL and make it clustered, but I don't know about the multi-master approach. But if you hit me up offline, very easy to find, I'll get an answer for you from our product managers. Great. Yes?
Speaking about clusters, if you create a database cluster, does it also create empty affinity rules in vSphere?
Yes, it does. Yeah. So the question was, when we talked about clustering databases, you know, you don't want all the VMs to end up on the same ESXi host, because if that host goes down, take them all down. So what happens is that when we cluster the databases and we build the replicas, there are DRS anti-affinity rules that will keep them segregated on different hosts in the cluster. Thank you. Any more questions? Yes, please.
Yes, I just want to hear if you think it will be part of Tanzu as a shared service or part of...
So, yeah, so this product originated in that Tanzu BU initially, but it was brought into, let's say, well, I don't want to bore you with internals of VMware, but essentially the infrastructure team, because we wanted to focus on the data. Like I said in the introduction, we've done bits, bytes, blocks for years. Now we want to move up the stack. So we thought that this product, if we bring it into that particular team, then we'll be able to focus more on the vSphere administrator aspect of this rather than the developer aspect. Now, there are still tools within Tanzu that will allow you to provision databases. There's Kubernetes operators for MySQL and for Postgres that you can continue to use and are still available as part of the Tanzu stack. But what we're focusing on here is the vSphere administrator. Sorry, you were going to ask.
So, yeah, but I am actually, well, I think that that our developers are interested in the database you became funny about the MS.
Right.
So I would expect that to be in Tanzu.
So again, because we want to support the full stack, including the database, then what we're doing is we're qualifying certain databases. And again, we're just going to focus on getting MySQL and Postgres done really well. And then who knows, in time, we may have the Mongos and the Marias and all of those as well. Is that okay? Yeah, great. Yes? Yeah, at the moment, yeah.
I almost forgot what I was going to ask. Updates for the databases.
Yeah.
Does that require the data service managers to be offline, or is there also a dark side option where you can import images offline?
Yeah, so the question is, let's say if you were air-gapped, in your environment was air-gapped, how do you get those images? How do you get those patches from VMware? There is a mechanism for you to download those images yourself and put them into an S3 bucket yourself as well. So there is an air-gap support for this product as well. Thanks, Chris. Any more questions? At the back, yes?
Yeah, we saw you initialize the database as such, but how far can you take it? Could you also create tables in the database and load the test data sets? Or would you do more specific configurations of the database from this tool?
No, you would have to use database-specific tooling to do imports and exports of that. We support you using it like any other database, but there's nothing in the UI workflow that would do that for you. But that's not to say that if you're automating the whole thing, you could absolutely just call those, import and exports to do the, pull in a CSV data set into a particular table. You could absolutely do that, but not in the UI. Yeah. Okay. Any more questions? Okay. Well, thank you very much for coming to my talk. I hope you have a wonderful evening, and take care.